All right, let's dive into a really cool cosmic puzzle that had scientists scratching their heads for decades. We're talking about some pretty mysterious messages coming from our own sun and how a team of researchers finally cracked the code. You know, imagine you get a text from a friend, but sometimes it's super loud and clear, and other times it's just a faint whisper, even though you know they're shouting. Well, that's pretty much what was happening with the sun. For years, it was sending out these really inconsistent signals that scientists just couldn't make heads or tails of.
But that all changed. And this is the exciting part. A brilliant team from the Indian Institute of Astrophysics finally had that aha moment. They solved this decades-old solar mystery, and today we're going to break down exactly how they pulled it off.
Okay, so to really get how they solved it, we first need to understand the clues. This means getting a handle on the sun's radio signals. Think of this as our little detective briefing before we crack the case wide open.
So what exactly are these signals? Well, they're called solar radio bursts. Basically, they're these intense blasts of radio waves that shoot out from the sun. They're usually tied to these massive solar events, like flares or what we call coronal mass ejections, CMEs. It's kind of like the sun letting out a massive shout, but in radio language.
And these bursts, they're incredibly important. They're like a direct signature of electrons getting shot out at high speeds in the sun's atmosphere. And get this, by studying their wavelengths, we can actually tell where they came from. Short wavelengths mean they started close to the sun's surface, while the long ones come from way farther out. Super useful.
All right, now that we've got the basics down, let's get to the real heart of the mystery. It's a classic story of two signals that just didn't add up, and it left researchers totally stumped for a long, long time. So, the puzzle is all about one very specific kind of signal. It's called a Type 2 solar radio burst. Now, these things are generated by these enormous shock waves that are just tearing through the sun's corona at unbelievable speeds. We're talking nearly 1,000 kilometers per second. It's these shocks that are the source of our two mysterious signals.
And this is where things get weird. See, these shock waves create two types of radio signals. A fundamental one, which is like the main note, and a harmonic, which is kind of like an overtone or an echo. Now, logically, the main note, the fundamental, should always be stronger, right? But what scientists were seeing often blew their minds. The harmonic, the overtone, was coming in more powerful. It was a complete contradiction.
So the big question on everyone's mind was what on earth was going on? How could an echo possibly be louder than the original sound? Why were these signals so frustratingly inconsistent? This was the puzzle that absolutely needed solving.
And this brings us to the big reveal. The breakthrough moment came when scientists decided to look at the sun from a whole new angle. And it changed everything.
It turns out the answer wasn't hidden in some complex physics of the radio waves themselves. It was actually much more simple, much more elegant. The secret was all about location, location, location. Where the event happened on the sun, that was the key.
After digging through the data for 58 different solar events, the researchers found this incredibly clear pattern. When an event happened near the center of the sun's disk, from our point of view here on Earth, the fundamental signal was stronger, just like you'd expect. But when the event happened way out at the very edge of the sun, what we call the limb, suddenly the harmonic signal was the one that came in loud and clear.
But why? Why does the angle matter so much? Well, it all comes down to how the signals travel through space. The sun's corona isn't empty. It actually bends and warps radio waves, kind of like a lens bends light. So when an event happens at the edge of the sun, the corona bends that main fundamental signal away from us, away from Earth. But the harmonic signal, it travels at a wider angle, so it can still escape and make its way to our telescopes. The harmonic wasn't actually stronger, it was just the only one that was actually making the trip.
So, look, we've solved a fascinating cosmic puzzle, which is awesome. But this isn't just some academic thought experiment. This discovery has very real, very important implications for all of us, right here on Earth, especially when it comes to predicting space weather. Because these massive explosions on the sun, they don't just stay there. The energy and all the particles they blast out into space travel across the solar system, and yeah, they can have a direct and pretty disruptive impact on our planet and all of our technology. And what kind of impact are we talking about? Well, this space weather can seriously mess with our navigation systems like GPS, making them less accurate. It can even cause satellites to completely lose their connection to the ground, a situation we call loss of lock. And in our world where everything is connected, that is a major, major problem. So at the end of the day, by understanding what these radio signals are really telling us based on where they come from, we can get a much clearer picture of what the sun is up to. And this leads directly to more accurate, more reliable forecasts for this kind of disruptive space weather, which gives us a much better shot at protecting all of our vital technology in orbit.
I mean, think about it. This team turned a confusing, inconsistent jumble of signals into a powerful new tool for understanding the sun. It's just an incredible piece of cosmic detective work, and it really makes you wonder, now that this one secret message from the sun has finally been decoded, what other cosmic secrets are out there just waiting for us to find the key? Thanks for joining me.